So we made it. We are at the final talk. So like Gabriel said, my name's Roux. Full disclosure, I'm relatively new to programming. I've only been doing learning programming and programming for about a year. And Python is my first language. But for the past decade, I've been in academia studying and teaching philosophy-specific ethics and logic, and also doing a lot of work on human behavior, skill acquisition, and especially research into learning models that explore not only how we actually acquire skills, but how to actually translate that into some sort of education system. So of course, my first thought when I decided to start learning programming was, let's apply all the stuff I've learned and see how well it works, right? So whether you're an app developer wanting to get into web development, or whether you're, like me, learning new programming skills, or you're learning a new language, new tech, a new framework, these are just sort of a few key points from my experience that I definitely thought that might help you and I could share with you. So most importantly, you need to think about doing rather than just learning. Coding is all about building something that in some way makes your life better, right? And in order to build something, you have to have something you want to build, not just something you care about, something you're passionate about. This allows you to be selfish with your time. There's so much tech out there. There's so many modules, so many libraries that it's a little bit overwhelming, especially if you're just, maybe you're just starting to learn Java or whatever. And building something specific actually allows you to really focus your time and energy onto a few key practical things rather than just learning a lot of abstract stuff. The example that I frequently use is that a carpenter that makes furniture doesn't really need to know how to build a house, right? So this was my biggest problem when I started. With a background in logic from philosophy, problem solving especially in programming, came very, very easy to me. But while I was solving exercises, I didn't know how to program my way out of a paper bag, essentially, right? I could solve problems, but I couldn't do much more. So it's only when I started actually building stuff, things that I cared about, things about music or databases for my parents or whatnot, that I saw my skills and passion for coding increase exponentially. And this is because when you're working on something you like, learning actually just it kind of happens. It's almost an afterthought. Incorporating failure into learning. It rarely works the first time, it rarely works the second time, or the third. I consider myself lucky coming into coding at this time because I'm very well prepared. This wire is going crazy. I'm well prepared for the challenges that sort of programming as a field presents. Specifically, I love failure. I love it because it's an opportunity to learn something, and because it means I'm getting better. I have this sort of warped view of success that says that if you're always successful, you're actually stagnating. The more successful you are, the harder it is to actually continually learn new things, to continually improve. And there's this prevalent idea in society that success actually is the straight line from A to B, and that's a load of bull, I would say, because success actually looks a little bit like that. To use a quick anecdote, when I was 13 and my parents sent me to karate against my will, my teacher said to me, and I'm paraphrasing here obviously, but he said the only difference between him and I was the fact that he'd failed more times than I'd even attempted. And of course that's a bit of a cliche nowadays, but it's extremely true, especially when it comes to coding. The larger and more complex that our programs are, the likelier the chance that something is going to go wrong is. You don't have a clue where to begin to fix it sometimes, and the error message, if you get any at all, sometimes feels a little bit like the computer is giving you a snarky middle finger. But if you embrace the fact that things are going to go wrong, if you embrace that things are going wrong for a logical and discoverable reason, and that there's a similarly logical and discoverable fix for what's going wrong, you're going to have a much better time, I promise you. Especially if you're really willing to learn from those mistakes, maybe write them down, maybe, be aware of them rather than just saying, oh, okay, I fixed it. Someone's always going to tell you that you're doing it wrong, and sometimes they're right. You're working at a company, let's say. Someone comes along, looks at your code and says, that's wrong, and then they begin preaching like your code is going to tear the earth open. And you know what? Especially if you're starting out in a new company or whatever, maybe they have some interesting things to say. But what does it mean, having something interesting to say? Are they talking about how to improve your logic using something you've never heard of? That might be interesting. Are they talking about a new library that might help you do things better. That's interesting. Are they saying that, good Lord, you've gone one character over the 80 character limit? That could be a little bit pointless. It's important to learn to actually identify when you should actually listen, right? There's very few absolutes when it comes to programming. There's no one way to rule them all. And the beauty of programming, at least to me, is that each problem has a myriad of solutions. Before I started learning Python, I actually did a little research on, where to learn, what to learn, and so on. And I put a little bit of a curriculum together for myself. And the most important thing on that curriculum, in my opinion, was actually learning about best practices from the start. It's actually how I found out about PEP 8 before I even learned how to really, work with functions. It's the reason I bought Clean Code, Code Complete, Pragmatic Programmer. I learned more from those sorts of materials. I learned more about programming than I did from any tutorials where you learned how to actually program. So it's important to think about what you're doing as a craft, because what we do is a craft. We build things. It's important to think of it as a craft that can be improved over time by applying some version of the Aristotelian feedback loop, meaning you do something, you think about it, you theorize on how to improve it, you apply, you test, and then you come back and you keep going around and round and round. It's also important to keep in mind that our field, like many other fields, but sometimes I would say more than other fields, it's full of people who love ancient and meaningless disputes about minutiae. And getting caught up in them is a headache most of the time for us, mostly because they're rarely productive. The majority of software is written with a useful purpose in mind, not to be critiqued. Certainly, that matters at the academic level, and believe me, coming from philosophy, I love talking about semantics and splitting hairs. But at the practical level, it doesn't matter whether that calculator app you've written is written using Python and fancy libraries or is written entirely from scratch in lol code. As long as it's optimized and fully functional and it makes sense in the way you've approached what you're talking about. Which brings us to the next point, which is, here's a one-liner that I found online that I was kind of just, it basically replaces the substring at by op on all lines of all files in place under a specified path. But it's a bit of a hot mess. Software is written for people to use in most cases. If your design isn't easy to use, what's the point? Smart fridges, home automation, they're awesome things for technophiles at the beginning, but they weren't easy to use, so they didn't actually have a market until they became, much easier to use, essentially. Same story with computers. Think about the whole, homebrew club coming to today's. Everybody's got a smartphone, they've got tablets, and so on and so on forth. A program's design shouldn't be a compromise-laden balancing act between complex user freedom versus ease of use, but it should be a marriage of functionality and ease of use. So if you think about, for example, yak shaving when we're setting up our development environments, right? Imagine you had to install everything you needed without pip. Imagine you didn't have virtual environments, so every time you needed to use a different version, you had to uninstall and reinstall. And that marriage could be, for example, somewhere that marriage could be found in the idea of the express versus custom installs in an installation wizard, right? Similarly, when it comes down to writing code, it shouldn't be written for you or your team. It should be written for somebody who's going to take over your project without direct contact with you or your team. Of course, there's the saying that well-written code doesn't need to be commented, and I certainly agree with that to a certain extent. And definitely maybe that 5-line function or a 10-line function that you wrote, very easy to read and it's clear enough what it does, but what about the overall logic of the program? Or maybe you're coming back to that program and you are, in a year and you forget how you came up with the solution, especially the little tricky spot where a few logical leaps were made. And it's much easier to make it easy to follow and understand as you're writing it rather than just sort of winging it sometimes. And what I found is that the most straightforward way to think through a program is actually to write it down in English. You begin filling in the details afterwards. So let's say you're, making a dungeon crawler or something, right? And you say, there's fail-state conditions. Afterwards, you go in and say, what's my fail-state condition? Maybe I got eaten by a monster. Maybe I fell in a pit of gummy worms and I drowned. You work your way down to the most minute thing. And the beautiful thing about sort of this is that you can it works two ways. You can either take this sort of semi-code document and turn it into a design Bible, or this is how you actually turn your design Bible into actual code. And at the end of the day, you just basically need to plug in code, and it becomes much easier because you don't have to worry about the logic of the program. You need to worry about the logic of each individual aspect of it. As a result, your code becomes much clearer, becomes much more focused, and it's easier to debug because when something's not working, it's not that you don't know why it's not working within the entire thing. You know why it's not working, and you know where it's going wrong. It's a little bit easier to debug, I found. When learning something, there's basically 4 things I found that are very important to kind of follow as a best practice. First of all, stick with the method. Do your research, find out, maybe take an online class, whatever, but stick with the method. Even if halfway through you're struggling a bit, you're going to see much better gains this way than if you're going continually if you're hopping through methods. Each sort of tutorial is styled to get you to the end in some way at some point. That's not to say you shouldn't branch out. Say you're struggling with something. Feel free to branch out, but come back to your method. One of the problems that I had, for example, is, when I started, I was jumping around a little bit, and at one point I started coming up against lambdas, and I'm like, what in the world is this? I hadn't even covered functions. So you can imagine how confused I was at the time. Take a break. Learning is much more effective, if done in short bursts. I play jazz piano. I practice by sitting down at the piano and focusing and practicing something focused intensely for about 5 minutes. Then I get up and I walk away. I walk away for half an hour. I come back later. I practice the same thing again. You experience huge gains this way because the way your brain works, your brain is excellent at short, intense bursts of synapse creation, which is exactly what's happening as you're learning. But it's really bad at doing it over the long term. So all those long study sessions that we all did in university and whatnot, I mean, I'm sure you can attest to how little you actually learned by the end of the week. You don't retain very much. Play. And I know this sounds a little bit weird, but practicing what you've learned is important. That's great, but it's only going to get you so far. More important than practice is play. And coding this would translate to maybe having a side project, something that maybe you're not doing for work, you're just doing for your own interest. Or maybe it means finding out an open source problem of a project that you care about, and you're using newfound knowledge to actually do it, to fix this problem or bug or whatnot. You're only going to learn what you're trying to learn if you're actually going to use it in a way that challenges you and forces you to understand, rather than using it in practice along with a tutorial, and then when your hand stops being held, you're just a candle blowing in the wind. And the final piece of the puzzle is teaching. Teaching, I would say, is actually the most important piece of the puzzle. To teach something effectively, you have to understand it. If you can't teach it, you don't understand it. So, go out to meetups, meet people who are new to programming, or maybe they're having trouble and whatnot, and you understand this, or you think you understand this, and start teaching them, start helping them. Go to forums, answer questions. You're going to be surprised by how much learning you actually do by teaching something. If you like doing something, you're always in a mindset to do it. Time, mostly, flies, and you find yourself thinking about what you want to be doing even when you're not doing it. And you find yourself solving problems, or at least maybe I'm different, but I'm pretty sure I'm not. The key to improving your code is not actually when you're sitting at your desk, smashing your head against the table because you just can't solve this problem. It's getting up, walking away, and allowing your subconscious to kind of work through the problem. It sort of gives you almost fresh eyes with which to attack the problem when you come back. Hemingway said of writing, write drunk, edit sober. And I think it actually applies to coding as well. Maybe not the drunk part, but let's take a little simple program. I was about a month into learning to code when I found a website and it has just a bunch of programming problems, and there's this one that said, write a little script that takes, I don't know, like the last 3 letters of string and puts them in the front. So I just sat down, I came up with this. It's ugly, it's a mess, but it works. And that was kind of the key thing. So I walked away, and I just got to thinking, about that little rotate function, and I said, well, hold on a second, this can actually look a lot better. So I kind of just worked through it in my head, came back, sat down, I came up with this, and obviously if you look at this rotate function doesn't even need to exist realistically. So after a little bit of tinkering, this was the end product. And obviously I changed the little for loop over there to include the cases and whatnot. I mean, it's a lot clearer, it's a lot more elegant, but it's a far cry from what was originally the first thing. And now maybe this is not how I would even start doing it today, but the takeaway is that you want to essentially edit. You want to think about your code and edit, because your first stab at it is not going to be perfect, and there are ways to improve it. And I'm sure you've all heard of the theory that it takes 10,000 hours to master something. If you think about it, with a 40-hour work week, if you work in some time off, some sick time, some holidays and whatnot, it takes about 5 or 6 years under the 40-hour work week to master something, and that's not counting the time you spent learning it. So my question is, why aren't there more masters at this thing we call coding? And it's actually because most of the practice we engage in when it comes to coding is useless. I wanted to throw up on the slide some statistics, but I couldn't find the actual source, and the sources I found were completely not credible. But there was a study done that something along the lines of only 30% or 30 to 40% of what we actually do in our day-to-day job is actual meaningful practice. So what is useful is actually purposeful practice. And I'll use a music analogy to kind of make it clear. Improvising in jazz is a bit of a complicated process, but one great place to start is knowing your scales, right? So you sit down, you learn those, you practice them, great. Can you play jazz? Or more importantly, can you play music? Not really. You still have to learn what scales are appropriate to play with what chords. You still have to figure out how to make what you're playing musical, how to say something that's exciting, that's moving, how to modulate keys, how to navigate chord changes. And you have to do this all on the fly while playing with 5 or 6 other people, while at the same time trying to express an interesting musical idea. It's a little bit daunting at first. But what it does, in order to be able to do this, it takes purposeful, intentional, and highly concentrated practice to bring all of these things separately, to bring them seamlessly together, right? And this doesn't mean hours of mindless repetition. 5 minutes, like I said before, 5 minutes, 7 times a day of that kind of intense practice will give you much higher gains than any sort of just rote repetition. When it comes to programming, that practice comes in the form of somewhat academic problem solving, essentially. Learning, for example, how to use, different search algorithms, which one is better suited for what task, how to implement those things. Sitting down and brainstorming ways of solving the problem instead of just hashing out your code. Sit down and force yourself to come up with 3 different ways to solve that one problem. It also comes in the form of reading code. Take that same problem, find somebody else's solution to it, go step by step, make sure you understand it. And I can't tell you how much I've learned actually about coding by just reading people's code and finding out new libraries, new ways to do things. And you might say, well, I don't know, I've been a system admin for like 20 years, there's not much new that you can teach me. But even then, and maybe especially then, I would say, there's people out there that can show you things. There's people out there that can demonstrate new ways of using old things that you've been using for a while and challenging you, which I think ultimately is what makes our work interesting. I think the one thing deep down that we all in this room sort of share is a love of challenging ourselves and coming up against puzzles that have various solutions and finding an elegant solution in the face of that problem. And that's really about it. So thanks everybody for coming, and yeah.
Great. Does anyone have any questions? Over on the far side.
Hi. Great talk. I was just wondering, have you found any, do you have any recommendations to be better conscious of the fact that when we are practicing something, it is actually purposeful practice?
It's actually hilarious. I was talking with a bunch of people about this. There's a sort of mental state called flow, which happens about you start working on a problem or something, and about 20 minutes in, you have no distractions, and you get into this sort of state where you're actually solving the problem. Purposeful practice, from what I've, the work I've done, seems to be just before you enter this, like you feel yourself entering the state, but there's something blocking you because there's something you don't understand. If you're able to identify what that something is, and that's a little bit more difficult, and there's various strategies you can do that, saying, taking, maybe it's a lack of knowledge type of thing, right? So then you obviously, like everybody else, you hit up Google and you say blah blah blah, or maybe it's a lack of knowing how to put logic in there, right? But once you identify that thing, you sit down and you say, okay, let's use this thing in some creative way, and you force yourself out of your own comfort zone, right? So rather than saying, for example, one of the things that I said to myself was, instead of learning how to do memorizing sorting algorithms, there was a few algorithms that I just wanted to see if I could come up with them on my own. So take bubble sort, for example. It's not a very difficult algorithm, but when I was, completely new, I was like, what's going on? So somebody explained the concept to me, and I sat down and forced myself to think about it. But I was also purposefully practicing loops. I was saying, I'm going to be doing this with loops because it seems the best way to iterate through a list, right? So I identified the fact that I had just learned how to use loops at that point, and I said, let's figure out how to do that. So it's a matter of identifying what you need to practice, which is obviously a little bit is sort of the more challenging aspect of it. But once you are able to identify that, sit down and do that thing in a creative way that challenges you, but that's not too difficult.
Just like to follow up on that, and that's particularly interesting because like when you were in school, you're in college or in university, you kind of like have to do that, but like once you kind of start working, that's kind of separated and like that's kind of your own responsibility, which is.
I'm actually going to disagree with you on that one. So I taught philosophy for 3 years here at U of T, and I have some very strong views against the education system. I don't think the education system, and I don't think most people in university or high school are actually taught how to learn. There's very few people who actually take away how to learn from the education system, and that's because it's based on scores and testing. And of course, you're going to say, well, it's difficult. How do you figure out if somebody can actually do this without testing them? And there's various ways, and that's a whole other can of that we won't get into. But I think what you take out of university, what most people take out of university, is learning how to figure out how to get themselves out of a scrape. And there's a few people who I would say a good number of people, but not the majority, who figure out that. It's not about learning how to use Python. It's not about learning how to use this. It's not about learning how to use this. It's about learning how to learn, right? So, for example, myself, I only know it's a year now, and I know Python, HTML, CSS, and a little bit of JavaScript. And everybody I talk to says, dude, you should know like 5 or 6 languages by now. And I said, you know what? I'd like to stick with these and really know what I'm doing and understand the concepts behind them, rather than kind of, fritter around like a butterfly that's looking for a good stick to land on.
Enjoyed the talk. I was just wondering, is there some kind of formula for it's kind of like what you were talking about, learning something purposefully. Like we know what we know, and we know what we don't know, or there's some things that we know. The old thing, this guy, when they were invading Iraq, he said there's the known knowns, the known unknowns, the unknown knowns, and the unknown unknowns. So, like, is there a way to figure out what the unknown unknowns are, or some kind of a formula for finding out what you don't know that you don't know? And,
yeah.
Sorry, it's a confusing question. But,
no, not at all. There definitely is, and it's a little bit of it's a bit of a multi-tiered answer, just because it depends on where you're applying it, who you're applying it to. So, I've had the experience of learning new disciplines several times throughout my life. Once I'd started studying education, so applying these things, I've gotten better at it over time. When I first started studying jazz piano, I was very aware of how much I didn't know. because you sort of look at the thing, at the whole body, and you have to say, well, I have to study chords, I have to study scales, I have to study harmony, I have to study, touch, I have to study this, and so on and so on forth. When I came to programming, it's similarly like if you're learning a new framework or a new language or whatnot, it's actually very easy to identify those things because you're not the first one to be doing it, because there's hundreds of thousands of people who have done it before you. So, and that's what I said about putting a curriculum together for myself. I walked through, I spent about a good 2 months before I actually started learning programming. I spent about a good 2 months doing research on what I needed to know in order to become a practical programmer, not just somebody who knows about programming in theory. It's a little bit harder to do that if you are doing cutting edge research, maybe, and you are the first person who is venturing into that field. Then the answer, I have no idea what to tell you at that point, except for, good luck. But Google is your friend, as always, and if you don't, a great way to start doing something is you're learning something, say, 50 things I wish, things I wish I would have known when I started learning Python, or things I wish I would have known when I started learning Django, or whatever. Because there's so many people out there who have written so many blogs about this kind of stuff, and it's actually very easy to kind of come to grips with what lies ahead of you and kind of figure a little bit of a stepping stone program for yourself. I don't know if that answers your question, but hopefully. Yeah. Excuse me.
Yeah, so I think I'm going to miss this, but I was wondering what your opinion on online tutorials were, because I don't find them that useful because there's no real challenge when you do them.
It depends what you're using them for. My first interaction with Python was, what's it called? Code Academy, Khan Academy, whatnot. I found it super easy. I found it super pandering, but it taught me the very, 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 very basics. So that's great. Afterwards, I jumped straight into MIT's course for Python. A lot more challenging. So it depends what you mean by online tutorials, because there's stuff at the very challenging end of the spectrum that you will find online, that is available online. And then there's stuff that's just, and there's nothing wrong with it because there's people at all levels. So for example, like I said, personally, I came into programming with literally having done, my master's in work and whatnot in logic. So a lot of that stuff came very easily to me. But online tutorials can be very useful, depending on what you're. I'm sorry, it's kind of a broad question.
So you're saying it's mainly helpful as a primer, but past that.
Yeah.
Okay.
Yeah.
Yeah, that's, I guess.
Towards the beginning of your talk, you mentioned about sort of recording your learning, and I'm wondering if I feel like this is something that I've heard people talk about a few times, and very few people actually do. Have you found a good way to do that, whether it's a set of tools or ways to actually remind yourself to record that stuff? I
mean, I use Evernote for a lot of stuff. So what I did is I just kind of made a notebook in there, and then I said, with various sort of notes, things I've learned from trying to debug a program, things I've learned from reading code, things I've learned from whatnot, notes from different classes I was taking, and then I would just kind of review those on a regular basis. Regular basis being like every 2 weeks, and then as you outgrow a certain phase of learning about a certain thing, you maybe don't review that stuff, but you review the stuff that's relevant to you. It's definitely very useful because it'll help you make connections. I find it helps you make connections to maybe you've learned something in you and then you've forgotten somewhat about this thing because you're concentrating on something else. You read about it and then say suddenly, oh wait, yeah, this actually flows together well with this and whatnot. It's a very useful tool. It's a little bit, there's no one formula I would say though to how to use it. It's very personal. I'm very good with writing notes. That's just me. Some people are, maybe you want to talk into your phone and record yourself and then come back and listen to it, despite that being a little bit more time consuming. If that works for you, then you know what, that works for you. If you want to draw, visual maps or whatnot, if that works for you, awesome. But recording stuff definitely gives you a perspective of where you've been, where you are, and it gives you sort of that feeling of momentum, and it allows you to progress faster, I would say.
Any other questions? Yeah, one on the far side. Making me work.
Purposeful practice often involves you going over and over a very detailed and specific problem, but in the beginning you mentioned to work on something that you really want to build and you are passionate about. So how do you reconcile this, like working very specific problems that you can improve and like track your improvement with working with the big picture that you are trying to achieve?
Yeah. So I'll give you a perfect sort of evolutionary example that I kind of grappled with. For loops are very easy to do and whatnot. So I found just all sorts of various fun problems on, there's various websites, one called Codavy, which I really enjoyed. And there's Checkio and Code Wars and whatnot, which present you with problems. And so that's what I used for purposeful practicing programming. There were just very specific problems that, they have a myriad of solutions, but I wanted my solution to use this specific type of method. So like, I really wanted to use classes in here. I really wanted to use for loops in here. Afterwards, I wanted to, when I was learning classes, which I was having a little bit of difficulty in terms of like, once you make a class and starting to move objects around and whatnot. So instead of using, I built, for my dad, he owns a music studio and he keeps track of clients with Excel and everything. And I said, you know what, I'm gonna build you like a little program that's basically a database, but I didn't know any database stuff at the time. So I just built my own database. It was rudimentary, it was, but it had the same functionality as very, very same basic, functionality as a database. And so I began learning how to actually manipulate and use objects and store data and move data. So despite the fact that I was building something that I was really interested and excited about, I had very specific goals in mind. Learn how to write data, learn how to read data, learn how to operate, play around with pick a library and so on and so on forth.
Great. Thanks a lot, Roux.